Good morning, my dear children. Welcome back to the lecture series of Maharashtra Board Grade 12 Chemistry. Today we are going to start with the next chapter, that is aldehyde, ketones and carboxylic acid. My name is 𝐒𝐵𝗶𝗃 and you are watching 𝐒𝐵𝗃 classes. Let's get started. So in this chapter also we have got three compounds. One is aldehyde, one is ketone and one is carboxylic acid. So let's start with aldehyde. What is aldehyde? It's the first oxidation product. It is the first oxidation product of primary alcohol. So what do you mean by this? First oxidation product of primary alcohol. Now if I write, this is the general formula RCH2OH. This is primary alcohol. CH2OH is the functional group for primary alcohol. When you oxidize it with any of the oxidizing agent, first you get RCHO. That is your primary alcohol converts into aldehyde. Okay, CHO group is your aldehyde group. This is the aldehyde functional group. And then the further oxidation of it, if you are using a very strong oxidizing agent, then the oxidation will not stop in this state. It will further oxidize to carboxylic acid. So it is RCOOH. COOH group is a functional group for the carboxylic acid. So see what we have written, it is a first oxidation product. This is the first oxidation product of the primary alcohol. Okay. And the general formula for aldehyde is RCHO. So these things are important from here. RCHO is a general formula where R is aliphatic or it might be aromatic group also. Okay, that we are going to see later. Now ketone. Ketone is the first oxidation product of secondary alcohol. Okay, now what is secondary alcohol? If I have something like RCHOHR or it might be R dash, different R or same R. CHOH is a functional group of secondary alcohol. When you oxidize it, you get R, C double bond O R. That is, it oxidized to ketone. The CHOH group is oxidized to ketone. So we have written that it is the first oxidation product of secondary alcohol. So this is your 2-degree alcohol. When it is oxidized, we get ketone. So this is the basic thing which we need to know about aldehyde and ketone. So what we have seen, the functional group for aldehyde, is RC double bond OH. So RCHO. CHO group is a functional group for aldehyde which will be always terminal. It cannot be in between. You know that this carbon has to be always a terminal carbon atom, and that is why this functional group is also called as terminal functional group, TFG, that is terminal functional group. Whereas the functional group for ketone is RC double bond OR. So you can see here ketone group is flanked by two alkyl group. That means it has to be always in between. Ketone group cannot be a terminal functional group. It is always in between. Okay, so this is the basic thing about the aldehyde and ketone. So see what we have written over here. In aldehydes, carbonyl carbon is bonded to at least one hydrogen apart from one alkyl or aryl group. Okay, the functional group of aldehydes therefore is CHO, which is called formyl group. CHO is also called as formyl group. Okay, and or aldehyde carbonyl group. So what they are saying, the aldehyde group, this is your aldehyde group, is bonded to at least one hydrogen apart from the alkyl group here or aryl group here. This group can be alkyl or aryl, but it has to be bonded with at least one hydrogen. So this CHO group is also called as formyl group. This is known as formyl group, or this is also called as aldehydic carbonyl group. Aldehydic carbonyl group. Okay. On the other hand, carbon is bonded to two alkyl or aryl groups, either identical or different. it is called ketonic carbonyl group. Carbon is bonded to either identical or different alkyl or aryl group. So this is your CO, this is a carbonyl group. Now either it is bonded to the same aliphatic alkyl group, or it is bonded to different alkyl group, R and R dash are different, or it is bonded to one aromatic and one alkyl group, or it is bonded to two aromatic group, then it is called as ketone. So depending on what alkyl or aryl group it is attached to, same alkyl group or different alkyl group it is attached to, it is called as, it will be classified as different ketones, okay. But this ketonic carbonyl group, this is called as ketonic carbonyl group, ketonic carbonyl, okay, or it is also called as oxo group, okay, oxo, it is also called as oxo group. So ketonic carbonyl group, or it is also known as oxo group, okay. So functional group of carboxylic acid is COOH, called carboxylic group. Now the third compound, that is carboxylic acid, whose functional group is COOH. So it is like R C double bond O OH. This is COOH group is called as carboxylic acid group, okay. Now this CO group is the carbonyl group and OH group is a hydroxyl group, okay. This is carbonyl group and this is hydroxyl group. So when we combine together, it is carboxyl group, okay. So that is your carboxylic acid. So now we proceed towards the next topic, that is a classification of aldehydes, ketones and carboxylic acid. So first we'll see the classification of aldehydes. Aldehydes can be classified as aliphatic aldehyde and aromatic aldehyde. There are two classifications, aliphatic and aromatic. Now when we talk about aliphatic aldehydes, the compounds in which the CHO group or the formyl group is attached directly to sp3 hybridized carbon atom, that is saturated carbon atom, are called as aliphatic aldehydes. That means what? The formyl group, first I am drawing the formyl group, this is the aldehyde group or formyl group. This is directly attached to a sp3 hybridized carbon. Now what is an sp3 hybridized carbon? sp3 hybridized carbon is this, which is having all single bond, okay. So this carbon is the sp3 hybridized carbon, or it is a saturated carbon. Saturated carbon means carbon-carbon single bond, okay. So these bonds might be hydrogen or they might be again carbon, that's a different thing. But this formyl carbon is attached to a sp3 hybridized carbon or a saturated carbon, then it is called as aliphatic aldehyde, okay. For example, this particular aldehyde is called as acetaldehyde. This is an acetaldehyde, okay. This is an aldehyde of two carbon atom. So two carbon atom, in common we call it as ace, okay. So acetaldehyde, okay. So this is acetaldehyde, or the IUPAC name will be ethanal, okay. Ethanal is the IUPAC name. Similarly, if I have CH3, CH2, CHO. So this is an aldehyde with three carbon atom. So this is called as propionaldehyde. Propionaldehyde, that's a common name, and the IUPAC name will be propanal. Okay, so these are your aliphatic aldehyde. Similarly, if we see the other classification, that is aromatic aldehyde, in which CHO group is attached directly to an aromatic ring, okay. So now you see, this is your CHO group, this is directly attached to an aromatic ring. This is called as benzaldehyde, okay. Here CHO group is directly attached to an aromatic ring and there is another hydroxyl group in the second carbon atom. So this is commonly called as salicylaldehyde, okay, salicylaldehyde, or the IUPAC name will be 2-hydroxy, because the hydroxy group is attached to the second carbon. This is the first carbon. So 2-hydroxy benzaldehyde. So this is 2-hydroxy benzaldehyde, commonly called as salicylaldehyde. Here the aldehyde group is directly attached to the aromatic ring and nitro group is attached to the para position. So it is called as para-nitrobenzaldehyde. That's a common name. The IUPAC name will be 4-nitro, okay, because it is the fourth carbon atom, 4-nitrobenzaldehyde. So that is the IUPAC name of this compound. Okay. So I hope you understood the classification of aldehyde. So basically it is classified as aliphatic and aromatic depending on the formyl group is attached to which carbon atom. The formyl group is attached to the sp3 carbon atom. It is an aliphatic aldehyde, and if the formyl group carbon is directly attached to an aromatic ring, then it is called as aromatic aldehyde. So next we are going to see the classification of ketones. Similarly, like aldehydes, ketones are also classified as aliphatic ketones and aromatic ketones. So when we talk about aliphatic ketones, the compounds in which the carbonyl group is attached to two alkyl groups are called as aliphatic ketones. Now we know that ketonic functional group cannot be terminal, it is in between. So when the ketonic functional group is attached to two aliphatic carbon atom or two sp3 carbon atom or alkyl groups, two alkyl groups, then it is called as aliphatic carbon atom. This is a general formula. I already mentioned that this CO is called as oxo or ketonic carbonyl group. Now this R and R, they can be same or they can be different. If these R's are same, then we get simple ketone or symmetrical ketone, and if these R's are different, we get unsymmetrical ketone or mixed ketone. We are going to see that if we have simple ketone or symmetrical ketone where the ketones in which both the alkyl groups bonded to the carbonyl carbon are identical. Means what? This is your carbonyl carbon. If these two R groups are same, then we call it as symmetrical ketone or simple ketone. For example, suppose I have CH3, C double bond O, CH3. This particular compound is called as acetone. The common name of this compound is acetone, or in IUPAC we call it as propanone because it's a ketone of 3 carbon atom. So it is propanone. Okay. Similarly, if we have C2H5, C double bond O, C2H5. This is called as diethyl ketone. So you can see there are two ethyl groups adjacent to the ketonic carbon atom, carbonyl group. So we call it as diethyl ketone. Okay, IUPAC name is certainly different, but the common name is diethyl ketone. So this type of ketones are called as symmetrical ketones or simple ketones. On the other hand, if the two R groups are different, now this is R and this is R dashed. The two alkyl groups are different, which is the two alkyl groups which are bonded to the ketonic functional groups are different, then we call them as unsymmetrical ketone or mixed ketone. For example, we have CH3, C double bond O, C2H5. This is called as ethyl methyl ketone. So one side ethyl group is attached, one side methyl group is attached, so it is called as ethyl methyl ketone. Obviously, we are talking about the common name, okay? C2H5, C double bond O, C3H7. So here you can see one side ethyl group is attached, one side propyl group is attached. So this is called as ethyl propyl ketone. Okay, so we now understood what is symmetrical ketone and what is unsymmetrical ketone. Another classification is aromatic ketone, where the CO group, that is ketonic functional group, is attached to either two aryl groups or one aryl and one alkyl group. So either it is attached to two aryl groups like this. This is one aromatic group, then C double bond O, then again this is another aromatic group. See this example: aromatic group, CO, and then aromatic group. This is called as benzophenone, okay, or it is called as diphenyl ketone. There are two phenyl groups attached to ketonic groups, so it is diphenyl ketone, or the IUPAC name is benzophenone, okay, or it is attached to either one aromatic group, C double bond O, and this is aliphatic group, okay, alkyl group. So you can see this is aromatic, ketonic functional group, and alkyl group. This is called as acetophenone. Acetophenone is the IUPAC name, or it is called as methyl phenyl ketone. One side methyl group, one side phenyl group. So methyl phenyl ketone. Okay, so we classified ketone also into two broad categories, aliphatic ketone and aromatic ketone, depending on whether alkyl group is attached to the ketonic functional group or aromatic ring is attached to the ketonic functional group. Again, for aliphatic ketone, we have divided into two categories. One is simple ketone and one is mixed ketones. Simple ketones are those where the two alkyl groups are identical, and mixed ketones are those where the two alkyl groups are non-identical, that is they are different. Okay. So now we proceed to the classification of carboxylic acid, that is the third compound of this chapter. Classification of carboxylic acid. Carboxylic acid also can be broadly classified as aliphatic carboxylic acid and aromatic carboxylic acid. So aliphatic carboxylic acids are the organic compounds in which the carboxyl group, that is COOH group, carboxyl group is bonded to an alkyl group, are called as aliphatic carboxylic acids or fatty acids. For example, it is denoted as RCOOH, but this COH is attached to an alkyl group. Okay, this is an alkyl group. The carboxyl group is attached to an alkyl group. We can take example. Here one exception is there, formic acid. Where formic acid, this is your COH carboxyl group. This should be attached to a carbon, but here this is attached to a hydrogen. But still, formic acid is considered to be a aliphatic carboxylic acid only. Okay. Another examples are say CH3C_OH. So the carboxyl group is attached to a methyl group, an alkyl group. This is called as, it is a carboxylic acid of 2 carbon atoms, commonly called as acetic acid, and the IUPAC name is ethanoic acid. Another example we can say CH3CH2C_OH. So here again COH group, carboxyl group is attached to an alkyl group. This alkyl group is called as ethyl group. So the COOH group is attached to an ethyl group. So it is an aliphatic carboxylic acid, and the name of this acid is propionic acid. That's a common name. The IUPAC name is propanoic acid. Okay. In this case also we have to notice that the COH group is always terminal. It cannot be in between. Okay. It is always a terminal group, and that is why COH is also a terminal functional group. So here we have seen aldehyde is a terminal functional group and COH is a terminal functional group, but CO group, that is ketonic functional group, is non-terminal functional group. Okay. Another classification of carboxylic acid is aromatic carboxylic acid. These are the compounds in which one or more carboxylic acids are attached directly to the aromatic ring. So one or more carboxylic acid is attached directly to the aromatic ring. So this is carboxyl acid group which is attached to the aromatic ring. This is called as benzoic acid. Okay. Similarly, suppose this is one COH group attached to the aromatic ring. This is another COH group. There are two COH group attached to the aromatic ring. This particular compound is called as phthalic acid. This is called as phthalic acid. So this way we can classify the carboxylic acid. Okay. So what did we study in today's video? We have done 3 types of compounds, that is aldehydes. We'll just do the summary here. Aldehydes, then we have done ketone, and we have done carboxylic acid. These are the 3 compounds. Okay. Aldehydes, the functional group is RC_OH. This is a terminal functional group, TFG. Aldehydes can be classified as aliphatic aldehydes or aromatic aldehydes. Now aliphatic aldehydes are those where this R group is an aliphatic group, that is C_OH. This formyl group is attached to a sp3 carbon atom. This carbon atom has to be sp3 or it has to be saturated. Then we call it as an aliphatic aldehyde. Whereas aromatic aldehyde are those where the formyl group is directly attached to an aromatic ring. then it is called as aromatic aldehyde. Okay. About ketone, the functional group is R, C, double bond O, R. That means it is a non-terminal functional group. Okay, ketones are again classified as aliphatic and aromatic. Aliphatic and aromatic. Aliphatic ketones are again classified as simple ketone or symmetrical ketone and mixed ketone or unsymmetrical ketone. Simple ketone will be where the alkyl groups are same, mixed ketones where the alkyl groups are different. Aromatic ketone where the ketonic group is either attached to an aromatic ring, attached to both aromatic ring, or it is attached to one aromatic and one aliphatic ring. They are called as aromatic ketone. Carboxylic acids are also classified as aliphatic and aromatic carboxylic acid. So in aliphatic carboxylic acid, the carboxyl group is COOH group. This is attached to a aliphatic or alkyl group R, and aromatic carboxylic acid are those where the carboxyl group is directly attached to an aromatic ring. Okay, so this is the summary of today's video. So in the next video, I'll be coming up with the nomenclature of aldehydes, ketones and carboxylic acid, and then I'll start with the preparation part. If you feel these videos are beneficial to you, please subscribe the channel and press the like button.